Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 8, Graphs of Simple Nonlinear Functions. Nonlinear. Okay, classwork, Exploratory Challenge Exercises 1 through 3. Consider the function that assigns to each number x the value x squared. Do you think the function is linear or nonlinear? Explain. I think the function is nonlinear because the exponent is not 0 or 1. And by definition, the exponent of the variable being 0 or 1 will give you a linear function. 2 is not 0 or 1, so this is not linear. That's as basic as I'm going to get on that one. I'm not going to explain any more, but I can prove it if I show my work in this table. Develop a list of inputs and outputs for this function. Organize your work using a table, and then answer the questions as follows. So if I plug in a -5, my output x squared will be -5 squared. Now keep in mind, I'm only going to do this one time. -5 squared is not the same as -5 squared. These are two different things. If the parentheses is around it, it means -5 times -5. And a negative times a negative is positive, and 5 times 5 is 25. Okay? If I take this -5 squared, PEMDAS, you know, the order of operations thing, PEMDAS says do parentheses first, there aren't any. Then it says to do the exponent first, which is the 5. Then it says to multiply, which we're multiplying. So this really means -1 times 5 squared. So it's going to be -1 times 5 squared, which is 25. And -1 times 25 is -25. So therefore, they are not equal. But if our input is -5, that means we're doing this first version over here. So this is what we're doing. So we are getting rid of, so whenever you square a negative, you don't get a negative, you get a positive. That's all I wanted to explain to you. So if I take the -5 and I square it, -5 times -5 is 25. A negative times a negative is positive. 4 times 4 is 16. A negative times a negative is positive. 3 times 3 is 9. A negative times a negative is positive. 2 times 2 is 4. A negative times a negative is positive. 1 times 1 is 1. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5, or 5 squared, is 25. Okay, so let me get this out of the way here. And I want to point something out to you before we go any further. Okay, if we do an equation, an exponential, or an x squared, not an exponential, it's a quadratic. Okay, an exponential is when the variable is a power. Okay, notice what's happening here. So I'm drawing these lines here. I'm making a point here. So if I plug in a -1 and I square it, I get 1. If I plug a 1 in and square it, I get 1. If I plug in 4, it's 16. If I plug in -4, it's also 16. So obviously, if I graph this, which I'm going to do next, you're going to see some things happening. So it says, plot the input and output as ordered pairs. Since it's on a different page, let me just print this and bring it over. Okay, so here is that table that we just worked with, and now I'm going to plot those points. So the input -5, 25 means go left 5 up to 25, and it's halfway between 24 and 26. Be careful. -4, 16 is right here. -3, 9 is right here between 8 and 10. -2, 4 is down here. And -1, 1 is here, and then the origin 0, 0, and then we repeat over here 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. So as you can see, it's coming down, it's curving around to hit 0, turns and goes back up, and we have a mirror image across the y-axis. So obviously not a linear equation. What shape does the graph of the point appear to take? At this point, I'm just going to call it a curve. Okay, but it really is a parabola. That is the mathematical term. It is a parabola. Okay. E says find the rate of change using rows 1 and rows 2 from the table above. Okay. So, what are we going to do? We're going to take y2 minus y1 over x2 minus x1. Okay, so that's what rate of change means. Rate of change, or m, if you will, slope. I won't use m, but let's just say rate of change is y2 minus y1 over x. I can do better than that. y2 minus y1 over x2 minus x1. Okay, these are our y's. Y's are outputs. These are our inputs. These are our x's. Okay, so I'm going to input. This will be my y1. This will be my y2. So y2 is 16 minus my y1, which was 25, divided by x2, which was negative 4, minus a negative 5. Okay, and that is going to give me 16 minus 25 is negative 9, over negative 4 minus a negative 5 is negative 4 plus 5, or 1. So I get a rate of change of negative 9. So there's the rate of change between row 1 and row 2. Okay, now it says find the rate of change using rows 2 and 3 from the table above. So 2 and 3 are these. So my y2 is going to be 9. Okay, so y2 is going to be 9, y1 is 16. So if I write this again, y2 minus y1 over x2 minus x1, that is going to be y2, y1, so it's y2, 9 minus 16. So it's going to be 9 minus 16 divided by, and then I go up to the x's, and it's going to be negative 3 minus a negative 4. Negative 3 minus a negative 4. So 9 minus 16 is negative 7. And negative 3 minus negative 4 is negative 3 plus 4, which is 1. So that becomes a negative 7. Okay, so obviously it's not the same because it's not a line. If it was a line, it would remain the same forever. The constant rate of change creates a line. So moving along, now it says find the rate of change using any two other rows from the table above. So I will just use the last two. So if I use these last two here, y2 is 25, y1 is 16. So y2 minus y1 is 25 minus 16 over x2 minus x1. And I need to go back and get those. x2 is 5, x1 is 4. So it's 5 minus 4. And 25 minus 16 is 9. 5 minus 4 is 1. So the rate of change there is 9. Okay, it says return to your initial claim about the function. Is it linear or nonlinear? Justify with as many pieces of evidence as possible. It is still non-linear. So I'm not going to write all this, but the reason is, 1, x is to the power of 2, which is not 0 or 1. The other reason is when I found rates of change between points, they were different. In a linear equation, there's a constant rate of change. If I found the rate of change to be negative 9 in the first 2 points, then every other difference between any 2 points would also be a rate of negative 9. Okay, so there you go. Number 2. Consider the function that assigns to a number x the value x to the third. Do you think this function is linear or nonlinear? Well, again, I'm going to say it's nonlinear. And the reason is because the exponent is 3. The exponent is 3, comma, and 3 is not 0 or 1. Okay. Develop a list of inputs and outputs for this function. Organize your work using the table below, then answer the questions that follow. So keep in mind that a negative 2.5 to the third power x cubed, which is going to be my y, by the way, and these are obviously my x's. Negative 2.5 to the third power means negative 2.5 times negative 2.5 times negative 2.5. Okay? So negative 2.5 times a negative 2.5 is a positive 6.25, because a negative times a negative is positive. But then I'm going to multiply that by a negative 2.5. Okay? Okay, so I had 6.25 times a negative 2.5. And that is negative 15.625. So this comes out to be negative 15.625. So I want to say something about that. Negative 15.625. So a negative to the third power will stay negative, because a negative times a negative is positive, and a positive times a negative again will go back to negative. So negatives will give me negatives in cubics. And if I cube a positive number, positive times a positive times a positive is going to be positive. So negative 2 times negative 2 is 4, times a negative 2 is negative 8. Okay, negative 1.5, the decimals are a little trickier, so I'm going to show you another way to do it in your calculator if you have one of these. Negative 1.5, and you can hit the math button, and if you see number 3 here has this little 3 here, press that, and that is negative 1.5 to the third power, and that is negative 3.375. Okay, little shortcut on your calculator. Negative 1 times negative 1 is 1, times a negative 1 is negative 1. Okay, this I'm going to do as a fraction. Sometimes fractions are easier. Negative 1/2 times a negative 1/2 times a negative 1/2 would be a negative times a negative is positive, times a negative is negative. 1 times 1 times 1 is 1, 2 times 2 is 4, times 2 is 8, and that is a negative 1/8. Okay, and negative 1/8 is a negative 0.125. Okay, and I'll show you that. Negative 0.5, math 3, enter, is a negative 0.125. 0 times 0 times 0, 1/2 times 1/2 times 1/2. I already did this. It's here. It's just the sign's positive now. 1 times 1 times 1. 1.5 times 1.5 times 1.5, and 2 times 2 times 2, and 2.5 times itself 3 times is, whoa, what happened? 3.375, and 8, and 15.625. Okay, now I'm going to plot these best I can. Start with the 0, 0, it's easier, so I put a dot there. Go left a half and down an eighth is like right there. That's this number right, this point here. We just did this point. Now let's do the positive. Go right a half and up an eighth. So that's about right here. So right now, just doing those 3, it looks like it's a straight line, doesn't it? But watch what's going to happen as we go larger. Negative 1 is here. And we can already see that's no longer a straight line because it goes here and then it turns. 1, 1. Oh, I went 1, 2, by the way. So let me be careful with my unit of measurement. 1 is only halfway. So negative 1 down 1 is here. And positive 1 up 1 is here. Okay. So that's the ones. Now I'm going to do 1.5 and then 3.375. So 1 and 1/2, 3.375, somewhere around here, a little more than 3. And negative 1.5 down 3.375 is somewhere down here. Okay, and then we're going to do 2/8. That's the easy one. 2/8. And then negative 2, negative 8 is down here. So that's this one. And then finally 2.5, 15 and a little more than a half. So 2 and 1/2 and up to 15 and a little more. So over 2.5 down to 15 and a little more. Okay, so as you can see, it's turning, it's curving, it's turning, it's going back up. Okay, so it's a 180-degree rotation. If I rotate this 180 degrees, this point would land right there. Okay, so there we have it. We plotted them. What shape does the graph of the point appear to take? It's a curve. Find the rate of change using rows 2 and 3 from the table above. Okay. Row 2 and 3, let me change colors, are these two here. There's row 2 and row 3. So that is going to be y2 minus y1, negative 3.375. So let me write this, y2 minus y1 over x2 minus x1 equals negative 3.375 minus, okay, I really don't like going back and forth like this, minus a negative 8, which is plus 8, over x2 minus x1. So that'd be negative 1.5 minus a negative 2. And minus a negative is plus. So that's going to equal 0.375 would be 0.625, 5.625. Or is it 4.625? Okay, I'm going to put 4 for now, and then I'll check it. Negative 1.5 plus 2 is 0.5. So let's just check this. So we're doing negative 3.375 plus 8. And it's 4.625. Divided by 0.5. And I get 9.25. Okay. Next question. Find the rate of change using rows 3 and 4. I'll switch to blue. Using rows 3 and 4 would be these numbers that I'm circling in blue. Negative 1 minus that negative 3.375, so it's y2 minus y1 over x2 minus x1. Write this every time, it helps with memorization. And then we're going to use negative 1 minus a negative 3. So negative 1 plus 3.375 divided by, and my x2 is negative 1 minus a negative 1.5, which is plus. That is going to give me 2.375 divided by 0.5. So I'll get my calculator just to save time. 2.375 divided by 0.5 equals 4.75. So obviously we just proved this is not linear because my rates of change changed between 2 points, between 2 sets of points. Okay, if it was a line, we'd have gotten the same number for both. Find the rate of change using rows 8 and 9. I'll do that one in purple. So row 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9 is right here. So 3.375 minus 1. Again, I'm going to write this out. y2 minus y1 divided by x2 minus x1. Okay. So it is 3.375 minus 1 over 1.5 minus 1. Well, that's going to equal 2.375 divided by 0.5. And I just did that here, and that's 4.75. So rows 3 and 4 and rows 8 and 9 have the same rate of change. Okay. Return to your initial claim about the function. Is it linear or nonlinear? And I would say non-linear. Reasons? The exponent's not 0 or 1. It is 3. And the other reason? My rates of change are not the same for everyone. Number 3. Consider the function that assigns to each positive number x the value 1 over x. Do you think this function is linear or nonlinear? Explain. Well, if you remember the rules for exponents from Module 1 way back in September, 1 over x is not an appropriate way to represent a function. We want to, well, it is, but if you want to put it in exponential form, we do the reciprocal and make the power of x, which was 1, negative 1. So that equals x to the negative 1 power. So just by remembering that rule from Module 1, I would say this is non-linear because the exponent is negative 1 and not 0 or 1. Okay, now we're going to graph that. Okay, so here we go. Develop a list of inputs and outputs for the function. Organize your work using the table below and answer the questions as follows. This is y. This is x. 0.1 is 1/10. Okay, so I did this for a reason. X and 1 over x are inverses. They're reciprocals. So if I have 1 over 10 and I take its reciprocal, because that's what our output is, then I get 10 over 1, or simply 10. 2/10 is 2 over 10, which is 1 over 5. So this is 5. 0.4 is 4 over 10, which equals 2 over 5. So that's 5 halves, or 2.5. 5/10 is 1/2. Flipped over is 2. 0.8 is 8/10, which reduces to 4/5, which flipped over, or taking the reciprocal of it, is 5/4, or 1 1/4. The reciprocal of 1 is 1. 1.6 is 1 6/10. So let's do this over here. 1 6/10. Multiply 10 times 1 plus 6 is 16/10, which equals 8/5, and then we flip it. So this is 5/8. Okay, hopefully you're understanding how I'm getting these output values. And 2 is 2 over 1, and its reciprocal is 1/2. 2.5 is 2 and 5/10, which is 25/10. And 5 will go into 25 5 times, 5 will go into 10 twice. So I take the reciprocal of that, and it is 2/5. 4 over 1's reciprocal is 1 over 4, and 5 over 1 is 1 over 5. Okay, so there are our values. Now we're going to graph them. When x is 1/10, which is right about here, just off 0, I go up to 10. So I'm way up here at 1/10, 10. Then I go to 0.2, just a smidgen over, and I'm all the way down to 5. So right about here, 0.2, 5. Then I go to 0.4, which is not quite a half, and I go up to 2.5. So it's right about here. Okay, so this is not a straight line. This is turning. And then, where was I? 1/2, 2. So if I go over 1/2, I go up 2. I'm right about here. And then I go to 0.8. And up 1 1/4 is about here. This is tough to graph, but we do see what's going to start happening. And at 1, I'm at 1. So here it is. Now I can really start to see some turning. All right, so at 1.6, which is a little bit more than 1.5, right about here, I'm going up to 5/8. I drag my pen, so let's fix that. So at 1.6, I'm about there, 5/8. I go over to 2, I'm at a half. I go over to 2.5, I'm at 2/5, which is just under a half. 2.5 is a half. And then I'll go over to 4, I'm down to a quarter. And then 5/1/5 is here. So this looks like it's a little too high, so let's move it, because it can't go back up. So let's just set that, oh, I don't know. It's hard to see where it is. Maybe about there. Anyway, it's coming down, it's curving, it's getting closer and closer to 0 is what's happening. So it'd probably be easier for me to erase that P point and put it back in, like right there. Okay, so there it is. So it's coming down, it's curving, it's curving, it's curving, then it's coming out here, and something happens there that we don't do in this class. You'll learn that in a year or two. So C, plot the inputs and outputs as ordered pairs, defining points on the coordinate plane. So I did that. So I plotted 1/10, 10, and so forth. I just didn't write them as ordered pairs, but this is what it would look like. And that is that point right there, and so forth. What shape does a point appear to take? A curve. Find the rate of change using rows 1 and 2 above. So rate of change is y2 minus y1 over x2 minus x1. Okay, so let me move this down so I don't have to keep scrolling. Okay, so that's easier to do now that I can just look over to my right here. So now I have y2 minus y1. So now it said using rows 1 and 2, that's right here. y2 is 5, y1 is 10, so it's 5 minus 10 divided by y2, which is 2/10. I'm going to use these values here, non-reduced, because they're fractions. 2/10 minus 1/10, so 2/10 minus 1/10 equals -5 over 1/10. And remember our rule, that's -5 over 1 times the reciprocal of the denominator, which is -50. Okay, find the rate of change using rows 2 and 3. That is these, 2 and 3. So y2 minus y1 divided by x2 minus x1 equals 5/2 minus 5, which is 10/2. So I'm going to change that, over x2, which is 4/10, or 2/5. Let's do 2/5 because they both reduce to fifths, minus x1, which is now 1/5. So that is going to be 5/2 minus 10/2 is -5/2 over 2/5 minus 1/5, which is 1/5. And remember, whoops, not 15. Let me erase that because it'll take away more than I want. So let's just do this, 1/5. So remember the rule, it's -5 over 2. When you divide by a fraction, you multiply by its reciprocal. And that's -25 over 2, which is -12.5. So obviously these are not equal, so it's not a line. -50 does not equal -12.5. Okay, and we're going to continue. G, so I've already brought this one in. Find the rate of change using any two other rows from the table above. Oh, I don't know. Let's close my eyes and pick one. Let's do an easy one for a change. Let's do integers for x. So that's going to be y2 minus y1 over x2 minus x1 equals y2 1/5 minus 1/4 divided by x2 minus x1, 5 minus 4. Okay, I need to convert this to 20ths. So that's 4 20ths minus 5. 5 20ths. Okay, over 1. So 4 20ths minus 5 20ths is a -1/20th. Okay, and that equals a negative 0.5. Got my decimal place in the wrong location. That's negative 0.05. Okay, a 20th is 5%. Okay, now H says return to your initial claim about the function. Is it linear or nonlinear? It is obviously nonlinear. And how many pieces of evidence do we have? Well, our rates of changes are different. Our exponent is -1, and that is not 0 or 1, and I'm content with those two. Okay, so here we go. Exercise 4 through 10. Okay, in each of these exercises 4 through 10, an equation describing a rule for a function is given and a question is asked about it. If necessary, use a table to organize pairs of inputs and outputs and then plot each on the coordinate plane to help answer the question. What shape do you expect the graph of the function described by y equals x to take? Is it linear or nonlinear? Well, x is a power of 1, so I will say it is linear. And when y equals x, I'm not going to, well, yeah, I will. Let me get a piece of graph paper and we'll do this. Okay, so here's our graph. So we're going to plot this. So if it's y equals x, so if I have an x in a y table, -2, -1, 0, 1, 2, well, if y equals x, well, guess what? These are all equal. So I'm going to plot the point, -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. And obviously that is a straight line. I'm not going to take the time to draw it, but you can see that those are all on a line. So that is linear. Okay, number 5. What shape do you expect the graph of the function described by y equals 2x squared minus x to take? Well, I see an x squared here, so I know it's non-linear. And so now I'm going to do a table of values, x, y. And let's pick values again around 0, -2, -1, 0, 1, 2. So -2 squared is 4. 4 times 2 is 8. 8 minus a -2 is 8 plus 2, which is 10. So left 2 up 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 is up here a little bit. Okay, so I'm off just a bit. -1 squared is 1. 1 times 2 is 2. 2 minus a -1 is 2 plus 1, or 3. So then I'm at the point -1, 1, 2, 3. So that is right here. If I plug in 0, 0 squared is 0 times 2 is 0, minus 0 is still 0, so I'm going through the origin 0, 0. Right there. If I plug in 1, I'll get 1 squared, which is 1, times 2, which is 2, minus 1, which is 1, over 1, up 1. Okay, and then I plug in 2. 2 squared is 4, 4 times 2 is 8, 8 minus 2 is 6, so over 2, up 1, 2, 3, 4, 5, 6. Okay, so this is coming down, turning somewhere, coming back up. Okay, we haven't gotten to where it turns. That's a different course, but I can tell you that it is at 1/2. So there's another point down here somewhere, and that's why these points aren't lining up like they did before. Okay, but it's definitely not linear. That we proved. Okay, number 6. What shape do you expect the graph of the function described by 3x plus 7y equals 8 to take? Well, x is to the first power, y is to the first power, so I'm going to guess it is linear. But now I need to prove it. So I'm going to choose values, x and y. Okay. So unfortunately, this is not going to be pretty because we don't have any ones, so it doesn't matter which one we choose. There will be a pattern though. So if I plug in 0 first, that'll make my life really easy. 0, 3 times 0 is 0, so 7y equals 8. So this is in standard form, so how about we just do x-intercept, y-intercept? So find out what, let me move this up because we're not just going to start in the middle. Let's find out what y is when x is 0. Well, when x is 0, 7y equals 8. Okay, 7y equals 8. Divide by 7, divide by 7, and y is 1 1/7, or 8/7. So that's 0, up 1, and a teeny little bit more. Then I'm going to make y 0. And when y is 0, 3x equals 8. To solve for x, I divide by 3. and x equals 8/3 or 2 and 2/3. So I go over 2 and a little more, 2/3, 0. Okay, and if I keep doing that, it's going to fall on this line right here. So I'm not going to pick any more points, but it's going to be a linear function. Okay, and we're continuing. Okay, continuing. What shape do you expect the graph of the function y equals 4x cubed to take? Is it linear or non-linear? Okay, x cubed, not a 0 or a 1, non-linear. But let's graph it. 0, instead of doing a table, I'm just going to do it verbally. 0 to the third power is 0 times 4 is 0. So when x is 0, y is 0. We're at the origin. When I plug in 1 to the third power, 1 cubed is 1 times 4 is 4. Over 1, up 1, 2, 3, 4. So now I'm here. If I go negative 1 to the third power is negative 1 times 4, which is negative 4. So it's point negative 1, negative 4. This appears linear if I only plot 3 points, but if I keep going and I put 2 in, 2 to the third power is 2 times 2 is 4 times 2 is 8. 8 times 4 is 32. 32 is way up here, so it will curve. So here's what it's doing. It's coming up like this, and it's curving through like this, and then it's continuing up like this. And I didn't do a very good job of that, but it is a curve, and it's probably going to curve a little bit more there like that. Okay, but it is curved. Number 8, what shape do you expect this graph, 3 over x equals y, to take? Well, 3 over x equals y is the same as 3 times x to the negative 1. So since that is a negative 1, it is nonlinear. Okay, so if I plug in a 0, 3 divided by 0 is undefined. I cannot graph it. There is no value at 0. If I substitute in a 1, 3 over 1 is 3, so that's 1, comma 3. Plug in a 2, and I get 1.5 over 2 up 1.5, 3 halves. Plug in a 3, I'm at 1. So what this is doing is coming down like this, and it's going to keep doing that like so. Okay, to save time, I'm just going to come over here. It's going to do the same over here. It's kind of mirrored, and that's what it looks like. That is called a rational function. Okay, so it is definitely not a line. Assume that an input of x equals 0 is disallowed. Okay, I mentioned that. You can't divide by 0, so that's why there's no value for 0. Okay, so moving along. Same thing here. We now have this one. We have a squared value, so I definitely know it's nonlinear no matter where that 2 is. And now let's substitute values in. Again, I can't plot a 0 because it's undefined. If I plug in 1, 1 squared is 1, so 4 over 1 is 4. Over 1, up 1, 2, 3, 4. If I plug in a 2, 2 squared is 4. 4 over 4 is 1, so I go over 2, up 1. If I plug in a 3, 3 squared is 9. 4 ninths is a little bit less than a half. So I'm plugging in 3, and I get a little less than a half. So it's looking like the last problem did. It comes down like this, and it's going to do the same on the other side. I'm not going to bother drawing it, but it's definitely nonlinear. Okay, and finally, the last one. Interesting, I like it. What shape do you expect this graph to be? X squared plus y squared equals 36. So I definitely know it's nonlinear. I know what it is because of what I do and what I've done, and I've already done other upper courses, so I know what this is a graph of. But let's take a look at it, and let's choose a bunch of values. X squared plus y squared equals 36. And I'm going to do an XY table. Okay, so if I plug in 0 for x, that means y squared equals 36. And to find the answer, I have to take the square root of both sides, and I get y equals 6. Okay, so when x is 0, y is 6. So I go over 0, up 1, 2, 3, 4, 5, 6. I'm only going to do 4 points here, and you'll see what's going to happen. Okay, now I'm going to choose 0 for y. So I'm going to say x squared equals 36 because y is 0, it goes away. and I take the square root of both sides, and I get x equals 6. The square root of 36 is 6. So now I have the point 6, 0, which is 1, 2, 3, 4, 5, 6. 0 is right here. It looks linear right there for starters, okay? But now I am going to plot negative 6 for x. So that would be negative 6 squared plus y squared equals 36. Negative 6 squared is a positive 36 plus y squared equals 36. Subtract 36 from both sides, and I get y squared equals 0. Well, if y squared equals 0, then y is 0, because 0 times 0 is 0. So I get the point negative 6, 0, which is right here. So it looks like it's curving around like this, but I'm not done. So now I'm going to choose negative 6 for y and see what happens. So I get x squared plus negative 6 squared equals 36. X squared plus 36 equals 36, and when I subtract 36 from both sides, I get x squared equals 0, and if I take the square root, I get x equals 0. So I have the point 0, negative 6. Okay. Let me give you a hint here. We're going to need a compass to draw this. So let me get my compass. And if I put the center, okay, the equation told me that the center's here. We haven't done this yet, and if I come out to here and I draw a circle, look at what happened. Every single point that we just plotted, I'm off by a little bit over here, but you see that it will be a circle. So if I chose the point 3, I would get 4, 1, 2, 3, 4, 5, somewhere around 5, a little more than 5, and so on. So this is a graph of a circle, obviously not a line. Okay, that is the end of this lengthy lesson 8. Review the lesson summary and go do your problem set.